going to do very quick recap on lipids and proteins, and then we're going to continue with nucleic acid, and after that, chapter 3. Okay, for lipids, very fast, because we have learned this before. There are 3 classes of lipids: triglyceride, and you can call it as fats, or triacylglycerol. Second class, phospholipids, and the third one, steroid. And then we're going to differentiate between the saturated and unsaturated fatty acids, or fat. So first one, which is triacylglycerol, or fat. The most important thing we need to analyze the figures. The formation of the triacylglycerol from glycerol and fatty acids. So we have 1 molecule of glycerol and 3 fatty acids. Take note on the functional group of the fatty acids, this carboxyl group here. So these important functional groups to determine the fatty acids. All right, so this is condensation or dehydration processes. They're going to be 3 molecules of water will be eliminated or removed, and then the bond ester linkage will be formed. So look at the condensation process here. So this is the ester linkage after the removal of 3 molecules of water. So this is triacylglycerol or triglyceride, so a neutral fat. Okay. Then we differentiate between the saturated and unsaturated. This is the saturated fatty acids and unsaturated fatty acids. Take note on the functional group as well, carboxyl for both. And when we look at the difference between unsaturated and saturated, we look at the structure of unsaturated. There's a presence of carbon-carbon double bond here, and there's going to be less hydrogen. So another one is the kink shape of these unsaturated. When you compare with the saturated, there's a maximum number of hydrogen attached to the carbon skeleton. So maximum number of hydrogen. So these saturated fatty acids is tightly packed when you compare with the unsaturated. So there's a lot of spaces here. So these less tight packing that actually prevent the unsaturated from solidifying. So that's why unsaturated example is the olive oil or cod liver oil. So this is unsaturated. That's better for your health when compared with the saturated. So we're going to concentrate on the figures for structure of phospholipid. It contains the head, the hydrophilic head, and the hydrophobic tails. When we analyze the tails, the tails consist of 2 molecular fatty acids. So you can differentiate with the fats, because fats consist of 3 fatty acids. But this one, 2 fatty acids. 1 fatty acid is saturated, another fatty acid is unsaturated because of the presence of carbon-carbon double bond here and the kink shape. This is the hydrophobic tails because it's non-polar, consists of carbon and hydrogen. Non-polar, so it's hydrophobic. So less affinity towards water when compared with the hydrophilic. High affinity towards water, like water. So we look at the hydrophilic head of the phospholipid, consists of glycerol and attached to phosphate ion. Actually, this phosphate, PO4-, contributes to the polarity of the head for the phospholipid, and then attached to the choline group, which is positive charge here as well. And this phosphate that contributes to the hydrophilic characteristics of the head for the phospholipid. Okay, yeah? Next is the steroids. Steroids consists of 4 fused rings here. This is an example of cholesterol. Cholesterol is the precursor of to synthesize another types of steroids, and cholesterol is also important to manufacture vitamin D as a raw materials.